had talked about the word rational in our last chapter. Remember when we did the rational root theorem? Okay. Rational has the math word ratio in it, and a ratio is just a fraction. So essentially what we're talking about in this chapter, oops, too many eyes, are fraction exponents. Oh joy. Fraction exponents and radicals. Okay, so you've seen like whole number exponents. And I guess you've seen, maybe I should say, integer exponents. Because we know like 5 squared is 5 times 5, right? 25. Do you remember what 5 to the negative 2 does? Anybody remember what a negative exponent will do? It'll flip it. So it flips the 5. Instead of being 5 over 1, it'll be 1 over 5. So it'll be 1 over 5 squared, 1 over 25. Okay, so that's going to be important in this chapter as well. Maybe make a little note to yourself up at the top margin today. Negative exponents don't make things negative. Negative exponents don't make things negative. Negative exponents flip what they touch. So that might be helpful. Okay, before we get into more with this fraction exponents, I'm going to take a side note and talk about the radical. So, radical, or sometimes referred to as root notation, okay, looks something like this. I'm going to call it the nth root of a. So I'm going to write that out, what I'm saying over here. We say the nth root of a. And of course, we could put numbers in. So it could be the cube root of 8. You can also have some variables underneath, like the 4th root of x to the 8th. Or you can have like a whole expression, the square root of x squared plus 9, which is not x plus 3. You don't square root plus minus. But we're just saying it the same way, the nth root of a. So I know that sometimes in years previous, like you've used the word radical in place of square root, like you say like radical 3 and you mean like square root 3. But now like the radical is really just representing the symbol. Okay. So I'm going to point to this symbol right here and I'm going to say this symbol right here, that's the radical. So radical is really just a symbol. It doesn't necessarily mean square root. It's just a symbol that looks like that. It doesn't have to be a square root. And out front, this is called an index. Okay? And sometimes we can refer to it even as the root. Now, the one root that you're super familiar with, that's the square root, right? And what sometimes confuses people is that the square root looks like it doesn't have an index. Now, the reason why we don't write the index on the square root is because we use it so often. It's so common that we don't have to put the little number outside every single time. But because the square root is the inverse of squaring something, the index is 2. So if you ever see a radical with a little 2 outside, that's really a square root. And if you don't see an index, if you don't see a number, you know it's really 2. The index is never 1. So if you you don't see it, it's a 2. But I can, of course, change the index. So I can make it a 3. And you maybe have used this one before. This we call a cube root, right? And it's like very obviously not a square root because it has a little 3 out there. Okay, but the square root is so common I don't have to put the 2 out. And then if you go any further, it's not like polynomials. Like we don't have any other special names besides square and cube roots. So then we just call it a 4th root. So we don't get too crazy with the names. So you really just need to know square root, cube root, 4th root, 5th root, 6th root. If you call it the 3rd root, that's fine, but you'll hear me say cube root a lot. Okay, and that refers to the index or the root. Okay, that number outside. And then A has a special name. Okay, sometimes I refer to the thing that is like A as the stuff under the radical. That is not a technical term. Stuff under the radical. But we all see it, right? It's the thing under the radical. Its real name is radicand. Isn't that fun? Radicand. So you'll hear me sometimes in class, I'll say the stuff under the radical, or I might say the radicand. But I want you to know, like when I'm talking about the radicand, I'm talking about that thing that goes under the radical. If I'm talking about the root or the index, I'm talking about the thing outside the radical. Okay. Any questions on symbols and notations there? Okay, now I want to make sure that you know where this is on your calculator. Okay, so you know probably where the square root is, right? You guys do second, and then you have like an x squared, and it looks like a little square root above. Everybody's probably familiar with that. Okay, do you see the button above that looks like the caret? Oh, sorry, like an up arrow. I call it a caret. Okay, that's your exponent button. And then notice right above it, it's really hard to see because it's printed so tiny. But it's like xth root. Okay, so it can be used for any root. The key piece to know here on your calculator is you have to tell it which root to use. So like if I wanted to do the 5th root of 32, okay, hang on, I'll come around and help everybody. I see a couple of different calculators, so I'll come around to you guys individually here in a second. If I want to do the 5th root of 32 in my calculator, okay, I have to type the 5 because that's the index that I want. And then I have to type second caret or exponent, and it'll bring up like a little x with this what looks like the square root, the radical. And then I type 32. Okay, so you guys try that. I'm going to help the people with different calculators. Did you find one for you? You want that one with the x on it so that you can do a 5th root. Okay, you type 5 and then math. Math has this really cool menu. You see it down there, number 5? Good. Anybody else with a different calc? You find yours? Good. Did you find yours?
No.
Type 5?
But I can program those. The websites you used to do it look like they're from the 90s.
And then you see it down there, number 5?
I think it only is.
Did you find yours for me? And then, did you find yours?
Fire.
Isn't your default browser I can use Firefox.
You have to do it.
I use
And this calculator
Just kidding.
No,
It
what?
actually
Wait,
tells me
what's the
how-
E?
I guess it actually tells me how.
What's the one? What's the del preset?
Depends on what you're Microsoft.
But Chrome is not the default browser. It's like it's
You
the
have to install Chrome.
It's
Yeah, that's it.
it's Edge.
If you use Microsoft, you need to install Chrome.
So you want to do the
You
blue,
use Internet Explorer.
see how it has X
Safari.
root of Y.
Safari.
And
He's
you
big.
get that one.
Yahoo.
No, you gotta do yours backwards. So
Chat. I don't even have a
Chat room.
I don't even have a web browser. I just have a freaking Reddit launcher. It takes a while to get the answer.
Okay, the answer is
Q&A
Two.
websites.
okay.
Why did I know?
Forums.
All right, so maybe like if you need to write down in your notes how to work your calculator specifically, because I'll just do this little one that I know. But if you have a different set of directions, write those down for yourself. Okay. Now, on this slide, this is really important to have in your notes. We're going to talk about how we go about switching from radicals to rational exponents, to the exponents that are fractions, because little secret is fraction exponents are roots. So you know how like a whole number exponent just means multiplied by itself. Okay. A negative exponent means I'm going to flip what I touch. And a fraction exponent means I'm actually going to take a root of a number. I'm not going to multiply it by itself. I'm going to find the thing that multiplies by itself to give me that number. So we're going to start with the nth root of x. Okay. This could be any index, any radicand. This turns into x to the 1 over n. So I'm going to do like a few examples. If I do the square root of x, that's x to the 1 over 2. Because remember, even though I don't see it, the index on a square root is 2. If I do a cube root of x, that's really x to the 1/3. If I do a fourth root of x, that would be x to the 1/4. Okay? So you're kind of like noticing a pattern here. Here's something that I always say many times in this chapter. The root, or the index, is in the denominator. So if you're ever like, wait, what's my fraction going to be? Whatever your index is outside your radical, that's the denominator. Or if you have a fraction exponent, whatever's in your denominator, that's your root that you put outside the radical. So let's just verify like one that we already know is going to work. Don't we know the square root of 9 is 3? Okay. And what we're saying is that the square root of 9 could be written as 9 to the 1/2. So now I'm going to practice you guys putting a fraction exponent into your calculators. Give me a second, because I have something very important to tell you. Most of the time when I put a fraction into a calculator, like sometimes people get alarmed because they're like, I don't have a fraction button. And I'm like, I don't care, you don't need one, because a fraction is just division. Okay? So we're going to say 9 raised to, that's the caret button, and then you want to raise it to the 1/2. So anytime you're doing a fraction exponent, you have to protect it with parentheses. If you do 9 to the 1/2, and you can try this out, you're going to get a different answer. Okay, so the correct one is the one with parentheses. Try it now. You know that the square root of 9 is supposed to be 3. Are you getting 3? Okay, let us know if you're not getting 3 in your calculator. Okay. What happens on this one, 9 to the 1/2 without parentheses? What's the calculator going to do for you?
It's taking it to the first power and then divided by 2.
Yeah, it's going to go 9 to the first is 9, and then divide by 2. So it doesn't know that you mean do 1 divided by 2 first. It thinks it should do its exponents. It's following PEMDAS, parentheses, exponents, multiplication, division. So be aware of that. This is not right. This would give you 4.5, right? Okay, now, not all the rational exponents we're gonna use in this chapter are gonna be 1/2, 1/3, 1/4. They're gonna have other number because like there's other fractions, right? 3/2, 2/3, 3/4. Okay, so I'm gonna go back up to my top of this slide, and I'm gonna say similarly. So I have this statement right here. Okay, similarly, x to the m over n. So like let's say there's some number other than 1 in your numerator. Remember, the root that you're doing, or the index of your radical, is what's in the denominator. So we're taking the nth root. Okay, so I'm going to start my nth root of x to the m. Can also be written as the nth root of x raised to the m. Sometimes you might see it as the nth root of x in parentheses raised to the m. They're all the same thing. Probably my favorite one is this one right here. That's how I usually end up writing it. Okay, so before we do some examples with evaluating, I want you to put your calculators down. We're not going to calculate anything right now. Okay, we're just going to do like a little practice. Can you change forms? So I'll pull this one over here. Can you do the square root of 11 to the 5th and 6 to the 2/3? So this one's in radical form. Can you turn it into a fraction exponent? And this one is a fraction exponent. Can you turn it into a radical? My key piece of advice to you would be, where is the root in your fraction? The root is in the, where's the root? In the denominator. Everybody needs to be able to answer that in chapter 5. The root is in the denominator. Okay, so try to rewrite those real fast for me. Square root of 11 to the 5th. 6 to the 2/3. This has base 11. And I've got to create a fraction. I've got this exponent of 5, but this is not a radical, right? This is just like raising to the 5th. So that's like 5. What's the root on this? 2. That's 11 to the 5/2. Done. Rewrite it. If you have 6 to the 2/3, what root are you taking? Cube root. So that's the cube root of 6 squared. Or you could do the cube root of 6 squared. Cube root of 36. Or you could do the cube root of 6 quantity squared. Those are all the same answers. So like, don't get too caught up on that. Like, it all means the same thing. If you want to play around in your calculator, that comes out to decimal. Like, we don't know the cube root of 6. But they would all come out to the same decimal. Okay, so they're all really the same thing. Okay, now we're going to create a nice little chart in our notes. I'm going to put in my roots. I'm going to put 10 numbers in here. So you decide, are you going to use up 10 lines of your notes, or do you want to like squeeze like 2 in one line? Totally up to you. The nicer and neater you make your little roots chart right now, the happier you'll be if you're using it. So we're going to start with roots, and then we're going to find out what their squares, cubes, fourths, fifths, and sixths are, just so we're kind of like, okay, I've seen these numbers before. And I'll show you how to use it to calculate roots without a calculator. I guess I'm going to put 11 numbers because I'm going to start at 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm going to go 10. Yeah, that'll be a good base. Okay, well, to make the perfect squares from those roots, I just have to take those numbers and multiply them by themselves, right? So 0 times 0 is 0. 1 times 1, 1. 2 times 2 is 4. And you guys are like, I already know the perfect squares. We did them in the last chapter. 4 different perfect squares. So you can go down. Try to make it nice and neat. Okay. And in the last chapter, we also talked about cubes, didn't we? We know some of the perfect cubes. Of course, 0 is a perfect cube. You can take the cube root of 0. It's 0. 1 is perfect cube. Then I can just multiply 4 by another 2, and that gets me to 8. 9 times another 3 is 27, and I can go ahead and fill in. I think we went up to 216 last chapter. I'm going to go all the way to 10, just so that we've seen these numbers. Does anybody remember 7 cubed at all? 343, excellent. 8 cubed is 512. 9 cubed is 729. And the 10s are always easy because whatever the exponent is, that's how many zeros it has. So 10 cubed has 3 zeros, so that's 1,000. Now I'm not going to go through all the numbers on the next column, so I'm just going to do some of them. Okay, so for fourths, let's see, it starts 0, 1, 16, 81, 256, what is that, 625, and will someone check this in the calculator? 6 to the 4th is 1296. Okay. And then I'll do the one at the bottom. That one's easy. It has 4 zeros, 10,000. But I'm not going to fill in the others. If you want to go back and backfill, you can. At some point, I would be like, that number is big. I will use my calculator. And then I'm going to do some fifths and sixths. So 1, 32, 243, 1,024, 3,125, then I'm probably done. This one's going to be 100,000 because it'll have 5 zeros. And I'll put a few in my sixth column. 0, 1, 64. This will be 729. This is 4,096. And I think this one might be 15,625. Someone want to double check me on 5d6. Okay. And then 1 million. Okay, so how can I use this chart? Well, I want you to be able to, sometimes you'll use your calculator, but I also want you to be able to, think about these numbers, and, the more you experience the numbers, the better you're able to recall. But in the beginning, it might be a little bit tough for us. So if I asked you something like, what's the 4th root of 256? You could use this chart. Go to the 4th column. See if 256 is there. It is. Follow it all the way back to the root, and the root is 4. Okay, if I did something like the cube root of 600, I'm going to go to my cube column. I'm going to look for 600. It's not there. it's in between 8 and 9, but this must be one that I would have to use a calculator for. Like, that's not on the list. So it doesn't have a perfect root. Okay. Something else to be aware of here. When you're doing roots, do you remember in our conversations in chapter 3, what did we say about like the square root of negative 36? It's imaginary, so this is not real. Okay. But we also kind of like use that I as a helper. We said, wouldn't it be 6i? Then 6i times 6i would be 36i squared, which is 36 times negative 1, which is negative 36. And so it works. What if I do the cube root of negative 8? Can you think of a number that multiplies by itself 3 times to give you negative 8? Negative 2. Okay? Negative 2 times negative 2 is positive 4, times negative 2 is negative 8. So the cube root of negative 8 is negative 2. Odd roots of negative numbers are negative values. Are real, I guess I'm going to say. Even roots of negative numbers are always imaginary. And that goes back to like even like Descartes' rule of signs when we did that whole like plug in negative x for all the x's. If you raise it to an even exponent, it was going to come out positive. If you raise it to an odd exponent, it was going to come out negative. So if your root is odd and you have a negative number underneath, it'll be the negative value on that roots table. If it's even, then you can say it's not real, or maybe you use the I value. Okay. Depends on what part of the chapter we're looking at. Okay, so we're going to do some examples where we evaluate, and then I'm going to have you, I think, practice real quick with your groups as well. Okay. So I'm going to start off with some roots. You want to jot these down. These are quick and easy to write, and then you have a few examples. And I think overall, like everybody in here probably could have done these even without me today. Like you would have been able to figure it out. What's the cube root of 27? 3. You already knew that one, right? 3 times itself, 3 times will give us 27. Okay, what's the fifth root of negative 32 in parentheses? Negative 2. What, you can go to your chart, look under the fifth column, is 32 there? Yes. Follow it all the way back to the root, it gives you 2, but because it's a negative 32, it must have been a negative 2. So this inside parentheses is negative 2. And then if you cube it, negative 2 cubed is negative 8. Negative 2 times negative 2 is positive 4. Times negative 2 is negative 8. So, you know, another way that you could have done that, like this, remember that slide when I rewrote the x to the m over n? This is also like negative 32 raised to the third underneath, like you can put the x underneath. But by hand, without a calculator, would you really want to do negative 32 times negative 32 times negative 32? No. So it's easier to have that, like to root it first, make it small, and then make it bigger. Okay, so you're going to be thinking about those things. Okay, what about the fourth root of negative 16? Two I. Okay. Or you might say, like, not a real answer. Okay. It will depend, like, if you're solving, you can give me the i's. If you're just simplifying, usually we just say, like, there isn't a fourth root of negative 16. This is not a real number. But I'll accept either one on that. No, when you solve, yes. Okay. But there, okay, so when you do even roots to solve, you always add the plus or minus. But the positive root is called the principal root. So when I just say to you, like, we're just like doing a problem and say, what's the square root of 36? Don't you usually just say 6? Okay, so like if all you're doing is simplifying and not solving, you're just like making it nicer, you just give the positive answer. But if you're solving, you have to. Okay, now those are pretty easy because they already look like radicals. What about when they look like fractions? Okay, just no calculators. Put your calculators down. 81 to the 1/4. Well, I really don't know what 81 to the 1/4 is, like thinking about a fraction exponent. That does not really make sense to me right now if I'm just learning about fraction exponents. So what I know about fraction exponents is that the root is in the denominator. So I'm taking the 4th root of 81. 4th root of 81. And check your column, 4th, 81, follow it to the root, 3. Okay, 4 to the 3 halves. I'm taking the square root of 4 and then cubing it. Now, I could also write it as the square root of 4 cubed underneath, right? I could do that if I wanted to. I usually like to make it small first and then make it big. So what's the square root of 4? 2 cubed is 8. Okay, another way for you to have done that was to say it was the square root of 4 cubed. Right? I think that's what you were maybe thinking. And so then that's the square root of 64, which is also 8. So it doesn't matter where you put the 3, right? I just like to have it on the outside so I can make it smaller and smaller. Okay, now I do want to show you one thing about 81 to the 1/4. Okay. Okay, obviously we see the 1/4, so we know we're taking a 4th root. The big question here is, what are you taking the 4th root of? What is the exponent actually touching? Is it touching the negative? The 1/4 is really just touching 81. And there's really just a negative hanging out front. What would you need in order for it to be the 4th root of negative 81? You would want parentheses. Okay, so this is going to get some people because they're going to be confused about what actually goes under the root. This one would be negative 4th root of 81, which is negative 3. And this one is 4th root of 81. 4th root of negative 81, which maybe we say is 3i or not real. So I always ask the question, you'll hear me ask it a lot. What is the exponent touching? In order for it to touch that negative out front, there needs to be a set of parentheses around it. If there isn't a group of parentheses there, it's only touching that number 81. So you 4th root 81, and then you make it negative. It's like negative 1 times 81 to the 1/4. Okay, last two, and then I'm going to have you practice some. What did I add into these two problems? So you can see it. Put in that negative. Okay, so my warning to you at the beginning of class, negative exponents don't make things negative, they flip what they touch. They make reciprocals. I'm careful to not say opposite, because opposite to me really means change signs, which they don't. Okay, so 16 to negative 1/4 is going to flip what it touches, which is 16. That's going to be 1/16. And now it'll be to a positive 1/4. Flip what it touches, so flip the base, and then make the exponent positive. Well, that's really saying 1 over the 4th root of 16. And the 4th root of 16 is 2. So it's 1/2. Notice, because I had a negative exponent, the answer wasn't negative. It's still positive, but it made it into a fraction. And so it flips. And then 8 to the negative 5/3. Don't flip the fraction exponent, flip the base, the 8. So that goes below 8 to the positive 5/3. Remember, in your fraction exponent, your root is where? In the denominator, in the basement, right? In the denominator. So we have 1 over the cube root of 8 raised to the 5th. Well, that's 1 over 2 to the 5th, which is 1 over 32. I'm going to give each pod a set of 30 cards. And I'm going to give you just a few minutes. We have one other thing we have to talk about, solving equations. But in the 30 cards, there are 10 groups. So that means you're making groups of 3. The 3 cards that you put in a group all equal each other. Dump them out. There is one card that is a 9. It's not a 6. There are no 6s. So there's like a radical expression, there's a rational exponent expression, and then there's a number expression. And 3 of them go together. And you try to make as many groups as you can. If you leave your group so that I can see all 3 cards, I'll turn them over when I find a group of yours that I agree with. Do this, no calculator, everybody. Dump out those cards. Let's go. Spread them out. Make some matches. Talk to each other about roots and exponents. That's a 9. There are no 6s in the answers. I was thinking, but I should have drawn a little line in the time. What are you guys doing? Let's go. Matches. They're ratios, yes.
I didn't even know that.
I like that.
That's 5.
That's 5.
Or imagine I once have a. Wow, imagine having just the number 5.
What does 5 equal?
This one's 8. Allow me to relate this. 7. I have 7.
Are these like columns of matches?
That's 4. What's the square root of
4. 4.
Try to do it without a calculator, guys. You
8.
know how the exponents
Where's
work.
the 8 over? 4. Wait, what is? Cube root of 1. So 1. How about 1? There's a 1. Square root of 1.
Yep, these are all equal to 5. I agree. Let me see what's over there. There's too many. There's only a pair of 4, so one of those cards does not belong. Yes, exactly.
Ah.
Okay, I have a few. Is this 4? I have 2. I have 2. Negative 2? If there's negative inside, I might keep this. I thought it was
Maybe.
negative 3. So if 3 negative 2 is 3 is I have 9. That would just be 1 that equals 9.
not a current, so.
Yeah.
Many of them understand about non-binary genders. They don't have a specific pronoun.
So,
Then you have to. They want to be called they. That's so freaking personality disorder, whatever it's called. They split. I don't.
Yeah, I don't care.
We're in
You
the
need a filter out.
Yes, I know.
I barely have a filter, but you gotta.
Okay, I'll be right there.
Is 2.
Yeah, this is good.
So wait, where are these?
You need to turn it over.
30 to, this is 3, square that's -9. No,
No.
it's positive 9. Sorry.
Yes. I think we did it.
Good job, mix them all up.
That wasn't homework.
That's like
This
16
one,
Yeah, but this is like this and whatever. Yeah, so
whatever.
I still like God.
So,
It's only 16 questions with part A, B, C, D, E.
yeah, like all of them have like
A alpha, which has like 8 more subtypes to it. Really not like that at all. Just
A with alpha.
Okay, no matter where you're at, I'm gonna have you mix up your cards. I went around, most people are on the right track, but we got one set of notes we need to talk about real quick before we dismiss. I got 5 minutes left. Okay, I'm gonna use all of them.
And the subscript has a subscript. Wait,
Okay, so just kind of like mix them up
or not subscript.
and then put them in the baggie. You don't have to even zip the baggie shut, center if there's a opening for the air to leave. Okay, and then get this in your notes for me. We're gonna also on your homework have some problems where you're solving equations by using nth roots. So you're really good at solving equations with square roots, but now you can also solve if you have a 2 or a 4.
I had to look really
The guy.
Okay, so the equations on your homework are going to be like x to the n. And it could have other stuff in it, so you might have to like move things around, or x might actually be an algebraic expression. Okay. But you basically just need to take the nth root of both sides. So whatever power it's being raised to, you take that root of both sides of your equation. Okay, once you get that part isolated. And if it's an odd root, you're going to have one answer. It's going to be positive or negative, right? Like x cubed equals 8, the cube root of both sides, x equals 2. But negative 2 doesn't work because negative 2 cubed is negative 8. Okay. Versus if it's being raised to an even exponent, that's when we have to add that plus or minus, because we don't know, like if it's x squared equals 4, if it was positive 2 times positive 2 or negative 2 times negative 2. Okay, so I'm just going to run through some quick examples. They're not hard to write down, so if you want some examples in your notes, you can add them. X to the 5th equals 32. Well, I just need to get to my x, so I have to do the 5th root. And then I have to do it to the other side. That's an odd root, so there will only be one answer. It has to be the correct sign. What is the 5th root of 32? 2. So x equals 2. If I was doing 5x to the 4th equals 80, I wouldn't start by fourth rooting because I don't know the fourth root of 5. So start by dividing. Okay, get that x to the fourth alone. So x to the fourth equals 16. And now I will take the fourth root of both sides. Since that's an even root, I don't know if it was a positive times itself 4 times or a negative times itself 4 times, so I have to add my plus or minus. And what's the fourth root of 16? So it'll be plus or minus 2. Either one would work. Okay, I won't do these, but I just want to show them to you. I'll pull them up so we can see them a little bit better. I got too much space. What would you do first to solve here? Add 50 first. Okay, what should be your first thing here? Yeah, the x minus 1 is protected by parentheses, so cube root first, then add 1 to both sides. Okay, so you'll have to think about what order you should be doing things to solve. Okay, you can't add 1 if it's trapped in parentheses. Okay. Your homework assignment is on your gold sheet. We're going to do lots more practice, and you want to try to do this stuff without your calculator so that eventually you just know 4 to the 1/2 is 2, and 27 to the 1/3 is 3, and you maybe don't even have to think about the cube root. Okay.